Where there are more than one chemical involved, one of the chemicals is going to run out. Okay, so if you add exactly the correct amount of chemicals of both, then you can have potentially a 100% reaction. The problem is that particle theory says that after a while, when you've reacted most of the molecules or particles in your box, then you will find that the rest of them won't, it would take an enormous amount of chance to actually for them to collide and react. But let's say you've got a very simple scenario of a beaker filled with hydrochloric acid, and you've got a marble chip. Okay, so the marble chip, that's calcium carbonate. And I've used that example now a few times. Calcium carbonate reacts with hydrochloric acid, and it produces calcium chloride and H2O and CO2. Okay. Lovely. Okay. So we need two hydrogen chlorides or hydrochloric acid molecules, and this is now balanced, I think. Right. So what happens? Well, your chip goes in the acid, and it begins to bubble because it reacts with the acid in the container. And after a while, either it stops bubbling with the chip still being visible, so there's a little bit of chip left over, or the chip has completely disappeared in the acid, so there's acid left over. So either the acid is the limiting reagent, or the marble is the limiting reagent. So that's the idea. So what that means is that once the marble chip is used up, you can't produce any more calcium chloride because there's no more calcium carbonate to produce it from. And on the other side, you can't produce any more calcium chloride because the acid has been used up. So effectively what it sits in is now just a solution of calcium chloride and water. Okay, so that's pretty much it, actually. I'll give you an example. So let's say you've got the relative formula mass of the substances in grams, and if we have 100 grams of calcium carbonate and twice the relative formula mass of hydrogen chloride or hydrochloric acid dissolved in water, then it's 2 times 36.5 grams. Then that will give me 111 grams of calcium chloride, 18 grams of water, and 44 grams of carbon dioxide. And if I add those together, then you see that that's right, because we've got 173 on the left-hand side, and we've got 18 plus 44. Why we're doing this in my head? 52, 62. 62 plus 111 is also 173. So that's grand. But let's say we've got 100 grams of the marble chips, but we only have 36.5 grams of the acid. Then what does that mean for the production of calcium chloride? Well, if I only have half the amount of hydrogen chloride, then I can only react half of the marble chips with it. So in terms of thinking about it in those terms, it's fairly straightforward to say, okay, instead of 100 grams, I can only react 50 grams. And that will give me half of the calcium chloride, which is 55.5, and half of the water and half of the carbon dioxide. Why? Because that means that the hydrogen chloride is the limiting factor, and that I only have enough for half of the calcium carbonate, which will in turn give me only half of the calcium chloride, and so on. What I will have left in the solution is I will have 50 grams of calcium carbonate left in the solution, right? So that then balances out. But the numbers are not going to be as nice as this most of the time. So let's say the good thing is, I think with this one, we can pick some random numbers. Okay, so I'm going to leave it at 100 grams. But this time, and the limiting factor is, well, we don't know. What number shall I pick? I'm going to pick something horrible. 87. Is that horrible? 87 grams. Okay. So what would happen there? Well, okay, so if you're already familiar with this equation and you've got it written down and the relative formula masses, then you know that 2 times 36.5 is 73. And that means that this time the calcium carbonate is going to be the limiting factor. That means how much calcium chloride am I going to get out? Well, I'm still going to get out 111 and 18 grams of water and 44 grams of carbon dioxide. Why? Because all of the calcium carbonate is going to react, but some of the acid will be left over at the time. Okay. So let's say instead of 87, I've got 8.7 grams. Now, in this case, we know that there's not enough hydrogen chloride or hydrochloric acid dissolved in the water, so that it will react with all of the calcium carbonate. So the question is, how much of the calcium carbonate is it going to react with? And I know that in order to react at 100%, I need 73 grams of hydrogen chloride dissolved in the water. But I don't have 73 grams of the hydrogen chloride dissolved in water. What I do have is 8.7. So at maximum, what I will get is a proportion of this 73 grams, 100% possibility, reacting with my marble chips. So if 73 is 100% yield, and yield is just another way of saying it's an outcome, then that's how chemists say outcome, basically, how much, what my return is. Then how much am I getting for 8.7 grams? Well, how do I get from 73 to 8.7? And again, ratios is everything for me here. If I divide it by 73 and I times it by 8.7. So if I do that on the other side, then I can do that in percent. Or I can do that with the actual amount in grams. So it depends on what you're being asked for here. So let's do percent first. So if I divide that by 73 and times it by 8.7, then I've got 11.9%. I've rounded that slightly. And if I do it in grams, then I've got 13.2. And again, I've rounded it.
Please like and subscribe and let me know of any questions you'd like me to cover in the comments.